Hey guys, welcome to another lesson, and today we'll be looking at projectile motion. Right? So projectile motion is motion in the air that occupies two dimensions, meaning two planes, your x and your y plane, or your vertical or your horizontal plane. So compared to free fall, where it's just in your vertical plane, projectile motion occupies both planes while the object is moving, right? And we do it, and it's done with the use of gravity causing it to fall back to the ground, right? And with projectile motion as well, it ignores the fact of air resistance, right? So an assumption is made that air resistance is zero, right? So with projectile motion, it normally mimics this shape, right? So if we start here, let's say this is the ground, and let's say we kick a ball, right? So the ball rises to a max, and that's known as your maximum height, and then it falls back due to gravity down to the ground, right? So from where it starts to where it's ended, that's known as R, which is your range in the distance that it moved in your horizontal plane, right? Now, examples of projectile motion in everyday life is basketball. So shooting the ball with a basketball, that is an example because it goes up and then comes back down, right? And then golf, right? So to attain a stroke of the ball, especially for long distances, it's used of projectile motion, as well as for long jump, right? So in long jump, the aim is to actually get your maximum range, right? So the projectile is used in terms of getting the correct angle in order to get your maximum range, right? Now, the angle that we normally concentrate on to get maximum range is 45 degrees, right? And by the end of today's lesson, you will actually know why 45 degrees is the primary angle for getting your maximum range. Now, let's look at our analysis between our x and our y plane for specific terms. So the first term is your acceleration, right? So in your x plane, so that means this is our object, right? So our x plane means only motion here. So wherever the object ends, we're only focusing on your x plane, right? So your x plane, there is no acceleration in your x plane, right? So because remember, the object only falls due to acceleration of gravity, and gravity acts downwards, right? So if gravity is acting downward and the object is moving horizontally, then there is no acceleration, right? And for y, since y now is actually in your vertical plane, then that means it has acceleration, which is gravity, 9.81 meters per second squared, right? And then velocity. So since in your x plane there is no acceleration, then that means there is no change in your velocity. And if there is no change in velocity, then that means the velocity is constant, right? So whatever this velocity is in your x plane is the same value here, or wherever on the path of the object in that projectile motion. But for your y now, y states that because it changes, because you have an acceleration, right, then your y velocity will actually change with time, right? Because remember from previous lesson, we know that a is v minus u over t, right? The aim is to find this velocity here, right? So it's basically v equals u plus at, right? But the u there is ignored, and we're going to see why later on, right? So the vy, meaning your velocity in your y plane, your vertical plane, is just g times t. G there is your acceleration due to gravity. To displacement, right? And displacement means how far away from the original position the object is, right? So in your x plane, if it starts here, then that means how far from this part going horizontally is the object, right? So for x, it's your v, right? So remember, v in x does not change. So it's a v times the time. So let's say after 2 seconds, what's your displacement from this point? You multiply your v by 2. If it's 3 seconds, then you multiply by 3, right? And then for y, because this object, right, is coming from a maximum height, right? So in this case, this is when the object is being projected from a maximum height down below. So it's like hitting a ball from a cliff and it falls down to the ground, right? So we start with a height, which is h, plus half gt squared, which is taken from this equation from motion, that s equals ut plus half at squared, right? So this ut here is your original distance, and since it's starting from a cliff of height h, then we replace ut with h, right? So for half parabola, because projectiles move in a parabolic path, parabola means it's basically a curve, right? So it's a curve, a parabolic curve, right? So that's the projection of any projectile motion. So if it's a half projectile, meaning it doesn't start from ground up and then back down, it only starts from a height, then comes down, right? So for half projectile, your total time traveled from here to the ground would be square root of 2, the original height of where you're from, over negative g. And remember, g here is always negative 9.81. Your horizontal range, delta x, range here is from where it's being projected to where it landed. It's v naught, which is your original velocity that it leaves off with, square root of 2h, h again is your maximum, is the height at which it started from, over negative g. And finally, your final velocity, meaning what's the velocity of the object right here before it hits the ground, right? So the velocity right there is your final velocity v, right? And that's equal to the square root of v naught, which is your original velocity right there, squared plus 2h, again, your height at which it's being projected from, times negative g, and g there again is negative 9.81, right? So that's only when it's a half parabola, right? Meaning that it starts from the maximum and coming down. Now, if we start from ground and it goes up and comes back down, then that's a full parabola, right? And a full parabola with your velocity, it's still the same, right? So the velocity in your x is still constant, but we need to know what exactly it is, right? So here, because this is v, and if v is projected like that, then that means it has an x component and it also has a y component, right? So to make this v here, it has an x component to the velocity and a y component. So we're finding the x component here, which is, we make this be the angle that it's projected at, right? We notice now we create a right angle triangle there. So it's your adjacent side, which is vx, and your initial velocity, your hypotenuse. So that's cos. So that's how we get v1, which is the original velocity that it's projected with, cos the angle that it creates when it's being projected. And your vy, right? So vy now is your opposite to the angle, so that's why we get sine here, right? Plus gt, right? So why do you think gt is there? It's a good question, right? So gt is there because, remember, it's going against gravity here, right? So your vy value, we would have to actually compensate for that going against gravity. So that's why we add gt. And remember, g there is negative 9.8, right? So basically what we're doing is minusing gt, because we already have g as being negative 9.8. Then displacement, right? So displacement in your x plane, right? So how far does it move in your horizontal plane is your initial velocity times the time cos theta, right? And we see why it's cos again, because it's adjacent to the angle. And for y, it's we're using this same equation here. So s now becomes y, right? Ut would be u initial for y is v1 sine theta, 1 v1 sine theta times the t plus half a is g t squared, right? So hope you guys got that. And then finally, these three equations are used regularly, right? I love these equations more than these because these kind of gets complicated at times, right? So these only includes the angle. So once you have the angle and the initial velocity, right, we can use these equations to find the time it takes for it to complete its roll, right? So the 2 here is if it starts from, if it's a full parabola. If it's a full parabola, it's 2. If it's just half parabola, we ignore the 2 here, right? So please make a note of that. So the 2 there is because it's a full parabolic motion, right? If it's a half, then you take away the 2 there. The h, the maximum height, is v naught squared sine squared theta over 2g, right? And then r, which is your range, is v naught squared sine 2 theta over g. So this is sine 2 theta, this is sine squared theta, right? So what we're going to do now is to actually use these equations to do 2 questions, right? Let's put what we just learned into print. So based on the question, we draw a diagram, right? So the question basically says the object is projected from the ground level, right? So it reach a point 2 seconds later where the horizontal distance is 40 meters away and the vertical distance is 53 meters away, right? So the first part here says what's the horizontal velocity at this point, right? So the first thing that we need to know is, because we're given vertical and horizontal distance, right, then that means we're going to make use of those, right? So we have x equals v1 vi t cos theta from our previous notes that we just did, right? So the x here is the 40, v1 is unknown, t is 2 seconds, cos theta, we don't know the angle that it was projected at, right? And y is 53, vi still unknown, t 2, sine theta unknown, plus half g here, remember it's negative 9.8, t 2 squared, right? So in this case, because both has 2 vi, we make 2 vi the subject, so we divide by cos theta here, so we get 40 over cos theta, and here half of 4.9 times 2 squared, we get 19.6. Because it's negative 19.6, when we take it over, it becomes a positive, right? Remember, we're making 2 vi the subject, so we divide by sine theta. So now we have 2 vi's, we can equate both, so we get 40 over cos theta equals this plus this is 72.6 over sine theta, right? So from here, we cross multiply 40 times sine theta, 72.6 times cos theta, right? So in this case, right, what we did was we're going to make sine being divided by cos. So in this case, we divide by cos, and over here we divide by 40, right? So in this case, we can cancel the 40s and cancel the cos, right? So we leave back with sine theta over 72.6 over 40. 72.6 over 40 is 1.815. Sine over cos is an identity that you need to know at this point, which is tan theta, right? So therefore, tan theta is 1.815. So theta is a tan inverse of 1.815, and you get 61.15 degrees, right? So this is the angle that was projected at. So I have the v velocity there, and the angle is 61.15 degrees, right? But we know from this equation, right, that we can find the vi, right? Because now we have the angle and we have x. Or we could use this one right? So anyone you use, you'll still get the same answer, right? So I use this one, it's simpler, right? So it's 40, VI is unknown, 2 cos. Now we have theta to be 61.15, right? So we divide by 2 cos theta, right? And we get VI to be 41.45 meters per second squared, right? But it didn't ask us for VI, it asked us for the Vx of VI, right? So in that case, we need to use that we have VI. We can put Vx, which we know from previous, is VI cos theta, right? So VI is 41.45, cos theta is cos 61.15. Put that in the calculator, right? And we get 20 meters per second. So the Vx was actually 20 meters per second, right? So remember, Vx is constant throughout. So if it's originally here, at this point, it is same 20. And at where 2 seconds later, it is still 20 meters per second, right? So let's look at part B. Alright, so part 2 of A asks us to find the vertical component of the velocity, right? So we already found Vy, Vxr, so now it asks us to find Vy, right? But we know Vy is V1 sine theta plus GT. Remember, we just found Vi, so we substitute Vi, substitute the angle. G, again, is always negative 9.8, and T is 2, right? So this here is 36.31, and 2 times 9.8 is 9.6. Minus these two, we get Vy to be 16.71, right? And then part B of the question, final part of this question here, asks us to find what is the horizontal distance when this object reached the maximum height, right? So a thing to note, when the object is at its maximum height, Vy is always 0, right? Because remember, Vy is how much vertical velocity it has. When it reaches the maximum height, it's not going up any further, right? So that means y is 0. Same equation we're using. So Vy is 0. We have the 41.45 sine 61.15 plus negative 9.8 t, right? So we're using this to find the time at which it reached the maximum height, right? We found that to be 3.71 seconds, right? So now we can substitute that in our x, because we're finding x, the distance it is that it reached the maximum height, right? So we now substitute the time. Instead of 2, because 2 was not the maximum height, we found the maximum height time to be 3.71, and we get x to be 74.20 meters. Alright, so let's look at our final question. Alright, so our second question again is posted there, right? So this time, someone is jumping from top of a cliff onto water, right? In a parabolic motion, right? So first part asks us, what is the distance that is 0.8 meters away in our x, right? So let's say at 0.8 seconds, the person is right here, right? So we're asked to find what is this distance that it is away from the cliff, right? So we're finding x, which is just v0 times t, right? So remember, the person went off in a horizontal motion of 2 meters per second. So because they went off horizontally, then v0 is 2, because that's in your x-plane. So 2 times the time, 0.8, so you get 1.6 meters, right? So the person is 1.6 meters away from the cliff at 0.8 seconds. And then b now, sorry, asks us to find how high the person is, right, from the ground at that point, right? So we're finding y there, right? So remember again, y is h plus half gt squared. Have the h here because it started from a height and it's going down, right? So h, height of the cliff, 10, half g again, negative 9.8, t, 0.8, square that, right? And we get 6.86 meters. And finally, it asks, what is the distance that it is away from the cliff when the person is about to hit the water, right? So we're finding delta x. So what's this distance there, right? So remember delta x is v naught square root of 2h over negative g, right? So we have v naught, which is 2 times h, which is 10, over g, negative from the equation, and then g again is negative 9.8. So this becomes a positive number, so it's 20 over 9.8, which we get 2.04. Square root of 2.04 is 1.43, multiplied by 2, we get 2.86 meters, right? So there it is, guys. We just looked through projectile motion. I hope you understand something today, and see you guys next time, right? Thank you.